And I use this thing that you already know to hammer home some important points about trigonometry. So I know that you all already know this. Would anybody care to see the joke I made here? There's a joke in the title. Anyone? No? It's a geek check. Anyone? Anyone? Star Wars! Yeah, it's Star Wars fun. It's the way Yoda would talk. Yeah! Times 2, you get a free gummy bear. It's like when you open a bank account, they give you a toaster. They don't do that anymore. They give you money. Huh? All right, so let us begin. In the triangle I have right here, I'm going to highlight the three sides. Which of those three sides is the hypotenuse? Blue. Now, I'm going to ask, and I'm going to get the answer that I always get. I'm hoping that I get the right answer, but I almost never do. What is the hypotenuse? Okay, so when I draw this way, these are the hypotenuses? No. Well, now you get a gummy bear, because nobody gives me the right answer there. What does everybody always say?
The biggest.
It's the longest side. Because you can tell that by looking at it. You can't. Because if I wrote 1 and 1, you would not be able to tell that that was the longest side. So that is the exact right answer. It is the side. Now, what was the word you used? Across from the 90-degree angle. We have a math word, and I've said it before, I think, in this class, but I'm going to say it again. The hypotenuse is opposite. And I want you to highlight. I want you to underline it. I want you to put an asterisk by it. I want you to do one of those Mrs. Bad Crumble clouds that your grade 3 teacher wrote around important things on the board. I don't care what you do to remind yourself of that word. But that word is utterly important and integral to this entire unit. Learn it. And it does not mean opposite in that I am super, super handsome and the opposite is super, super ugly. That is not what I mean. Opposite in geometry and trigonometry, opposite means across the figure. It does not mean up or down or side to side. It means you go across. So I'm at the right angle, and if I go straight across the figure, that is the opposite side. Learn it, live it, love it. Everybody cool? Good. The hypotenuse is always opposite the right angle. Now, how do I know I have a right angle? It has the little box. If the little box is not there, is that a 90-degree triangle? No. Everybody with me? Right now, it is not a 90-degree triangle. What if I told you this side was 3, this side was 4, and this side was 5, but I didn't put that there? Is that a 90-degree triangle?
Yes.
Yes. Why?
Because 3 squared.
Because you can do the Pythagorean theorem. Everybody cool? If you don't have the numbers to prove it, and there's no symbol there, it's not 90 degrees, no matter what it looks like. Do you all understand that? Sweet. All right. So, it's across the nice. The legs are the yellow and the green. And they are interchangeable. And you already know this. One leg, we label it as A and we label the other one as B. But those letters do not matter. You were all taught this. a squared, b squared, c squared, which is wonderful to learn until I give you a question that looks like this. QRS. And believe it or not, I have had many students say, that's not a 90-degree triangle, Mr. Myers. You can't do Pythagoras on it. And I say to that student, why? And do you know what they say to me? Because it's not a squared plus b squared equals c squared. I know that, but people have sat in that desk in the 10th grade in this building and told me that you can't do Pythagoras there. Does that bother you? I hope it bothers you, because it sure as bothers me. So that is why, ladies and gentlemen, I hate this. When I think of Pythagoras, I say leg squared plus leg squared equals hypotenuse squared. Then it doesn't matter what letters you have. Okay? Now, when I first learned this, my teacher taught us this, leg, hypotenuse. I was like, his name was Mr. Bailey. Stop me if I've told you the story, but I'm going to tell it anyway. I said to Mr. Bailey, Mr. Bailey, that's a weird word. I'm not going to know it. And he said to me, Matthew, call it the hippopotamus. I said, what? If you can't remember the name, hypotenuse, remember hippopotamus. And I said, okay. Grade 7, test comes along. I have to write down the Pythagorean theorem. Guess what I wrote down? Hippopotamus. Because I couldn't remember hypotenuse. Guess what Mr. Bailey marked it? 0. Yeah, I know. Can you believe it? I wrote down what he told me to say. Now, I've got some distance from it now. I'm okay. Knowing what you know, knowing you know how to do Pythagoras already, because you already do, tell me what these two values are. That one and that one. I know we've used Pythagoras a little bit already this year, and you've used it in the past. Why am I doing it again? Because it is the basis of trigonometry as well. And of course, I'm going to have to discuss your calculators in a moment. What's the hypotenuse in the first one? 17, of course. Absolutely correct. Come over to this one. What's different? I have the hypotenuse. So, we know that leg squared plus leg squared equals hypotenuse. So, all you got to do is x squared, because that's one of the legs, plus 8 squared equals 12 squared. X squared plus 64 equals 144. X squared equals 80. X equals the square root of 80. I know the screen is blue. That's what I did. I did algebra and I subtracted. The reason I didn't write it as subtraction, Nathan, is because I want to reinforce the algebra. You could, of course, have done hypotenuse squared minus leg squared equals leg squared. You could have done that. But I like to reinforce the algebra. So here was minus 64 to get 80. Yep. Now, the reason I'm spending a lot of time with this, even though all of you know how to do this, is because the whole next unit requires you to use your calculator on every single question. And every single question requires you to punch something into your calculator that, for about probably 5 or 6 of you, is going to be the complete opposite of what it is for the other 25 of you. Okay? So listen to me carefully. You do not need to write this down. When you are finding that square root, because that equaled hypotenuse squared, right? If you do this, if you go square root button, then 289, then equals, you have what I call, and it's got a special name, but I'm going to call it this, a forward calculator. If you had to do it backwards, you had to go 289 square root, and then you don't need to hit the equals button. You have what I call a backwards calculator. You need to know what you have, because after today, you're going to use your calculator every single question in this unit, and the way you have, or the calculator you have, will change the way you enter what we are doing. Okay? So know what you have. Do I have any backward calculator people in the room? Just one? That's the all-time low. Excellent. It does not, your calculator will do the same thing, but you will enter things differently. As long as you know what you have, that's fine. Everyone's good? Okay. Come back over to here. We are only going to talk about this one right now. Somebody, you can work with a neighbor, you can work by yourself, I don't care. Tell me what x equals. Go. I am betting that some of you have some of the following answers. Does anybody have 26.9? Okay. Does anybody have 17.3? Okay. Does anybody have 17.5? All right. So, most of you had 17.3. And I am guessing that, no, I don't want to guess that. Would anybody like to say how they got 17.3? The math that they did. Nathan, what did you do?
20 squared minus 10 squared equals 300.
So you did 20 squared. So you said this side was 20.
Yeah.
And you did 20 squared minus 10 squared and square root.
Yeah.
Okay. Is that what everybody, now that somebody has risked it, is that what everybody did that got 17.3? Okay. Is that allowed? Okay. So how did you know this was 20? Pardon me? How do you know this line right here is 20? How do you know that? Did you measure it? Did I put one of these there? So, is that 20? Not necessarily. Why would I give you this question? To see what you would do with it. I'll ask again. Find me x. So now you know that if you did this, that's not right. Jacqueline. Please do.
Okay, so across from the 90-degree angle, I said that was C.
Okay.
So that if it's connected to the other triangle, then I just find C like I normally would.
So you went over to here, and you went 35 squared minus 20 squared and square rooted to get that. No, what did you do?
I did 35 squared plus 20 squared equals, and then because I'm using that as the C equals whatever C is in square roots.
Uh-huh. Okay.
I just did it with the other triangle, I did 10 squared minus whatever C was
Yep.
to equal X.
Yep. Okay. But that would mean that this triangle was 90 in some way, right? Is it? Why not? Just one sec.
Well, you said it could be 90 without the,
Yeah, I said it could be 90 if the numbers work, right? Okay. So that would make this the C in the pink one, yes? Which would make this 90. Okay. But is it 90? So can I do Pythagoras on this triangle? No. Can I find X? No. You people do not yet have the math to find X. Unless you're from another country and you've already done trigonometry. You can't find X right now. How could I make it so you could find X? If I put this there, can you find X? Yes, because what will you do? What will you do with this pink triangle now that you know it's 90 degrees? You'll do Pythagoras to get this side, right? Is this an A, B, or a C? In the pink triangle. It's an A in the pink triangle, right? But what does it become in the green triangle? C. That's why I don't like using A's and B's and C's. That's why I like using legs and hypotenuses. Everybody cool? Okay. What if I told you, what if I put those in there? Could you find X? Yes, because how long would this side be now? 20. Excellent. What if I told you this all the way down was 90 degrees? How would that help you? Could it help you? Does it help you? How? It does help you. It does something to the big pink triangle. If I tell you that this is 90 degrees, then how long is that green line? 10. When I drew that green line, it went straight down. What did I make here? A 90. That makes this green triangle, yes? If I know I have the hypotenuse and I have that, don't I? Will that give me this side? So I could know this side because that side is going to be the square root of 20 squared minus 10 squared, yes? And then 35 minus that would be here, wouldn't it? Then I could do Pythagoras on this triangle to get C, and then I could go up there. Does everybody understand? When you learned, I'll talk more in a sec, Jacqueline. When you learned Pythagoras in grade 6 and grade 7, the whole question was that, wasn't it? One triangle. Find the answer. Move along. Agreed? Okay. We, in trigonometry, use knowledge from one triangle to solve other problems. That's how trig works. That's why we do it. Okay? So, we have to be able to see future stuff. All right? So Jacqueline, what I just did there, and that was the most complicated way to do it, if I made this 90, that becomes 10. You're cool with that, right? Which makes a new right angle triangle right there, yes? Which means this side is 20 squared minus 10 squared, and I square root. And that gives me this part of the triangle, yes? I know that the whole line there is 35, yes? So if I know this part must be 35 minus this part, right? Then, because I know this, and I know this is 10, I can find this in the blue triangle, right? And then I can use that answer from the blue triangle to find x in the red triangle. All we're doing is Pythagoras over and over and over again. The point of this whole lesson, this whole exercise, was that you cannot assume. You must have proof. Okay? And this question, as it's written right here, you cannot do it yet. Everybody cool? All right, knowing what you know, tell me if you can do the second one. If you can do the second one, do it. If you can't, make some adjustment like I made up here so it's doable. Do you understand what I'm saying? Either do it if you can, or add to that drawing so we can do it. And I will let you do that. Once again, do we know what vertex means? What is it?
Like where the two lines meet?
Yeah, it's the corner of an angle. Okay? So since a triangle has three sides, it has three vertices. The vertices are there, there, and there. So this triangle, we could name it triangle ABC. Everybody cool? And we always use caps. Now this triangle could also, it has two other names. What are they? Nope. Just change the order of the letters. CBA, CAB. Everybody cool? Does everybody understand? All right. That's how we name the triangle. Triangles are made of three sides. We've talked about their vertices. What's the other thing triangles have three of? Three sides. The sides are named by their opposite. And what does opposite mean? By their opposite vertex. And we use small letters. So, the way you were taught this before, you were probably taught that this green side is side AC or side CA, right? Because it goes from point to point. Yeah? Now we like to do it this way. Opposite vertex. So what is the vertex that is opposite this green side? B. So this side would be little b. Everybody understand? Little b. That's the way we're going to do it now. So you guys name the other two sides. Give it all three names for the other two sides. Go. It should take... Everybody name them right. Lil B, Lil A, Lil C. Everyone's good? Okay. So now, do that same thing on the big triangle. Name the sides, just using the way we're going to do it in the 10th grade. Just use the small letters.
Couldn't you also kind of say the side is not happening?
Pardon me?
Couldn't you also kind of say, like, say, since D
Yeah. Whatever you need to remember it. I try not to do that, Nathan. I try to use the math terms. The math terms is you name the side by its opposite vertex. So what's this side right here? Lil F. What's this side? Lil E. What's this side? Lil D. Everybody good? Everybody cool? Okay, now I'm going to change to my camera because I used to get kids to do this, and then I found out that you guys are sometimes not so hot at using protractors. So, if you know how to do this, you should be able to tell me the value of angle A. Oh, son of a bee. $31 degrees. Everybody happy? Everybody can read it, right? Okay. 31 degrees. Then you should be able to tell me the value of angle B. 55. Now you should be able to automatically tell me the angle of C. Why? 360?
Oh no, 180.
180. So how big is angle C? No. That's 31. That's 55. It's 94. Why? Right. Angles. Oh, you can't see that. Angles have to add up to 180. Now, on this triangle, looking at angle F, what is angle F's value? 31. What is angle E's value? 55. What is angle D's value? Automatically. 94. Excellent. Now, remember, angles add to 180 degrees in a triangle. It'll come back. It'll come back. It'll come back. It'll come back. Just like it was supposed to. All right, everybody's cool? We measured these two so we knew the third one. Because the angles have to add up to 180. Everybody good? Okay, now, the next thing and the thing that's important on this page is this. What do you notice about all three angles? They're the same. If all three angles match, the triangles are similar. And please highlight that word. And we would show this in a math class by doing this. Triangle ABC is similar, a squiggly equal sign, to triangle what? FDE? FED. Why is this one alphabetical and this one not? You have to follow the order of the first one. We went from 31 to 55 to 94, so down here we have to do the same order. Is everybody cool? All right. Now, turn the page over. Most of this chart is not important. We already know the angles, right? We knew A was 31, B was 55, C was 94, and F was 31, E was 55, and D was 94. We already knew all that, right? So now I want the lengths. Now again, whenever I got students do this, I'd get like 18 different answers. How many answers can there be to the question, the length of side A? One, because everybody reads rulers poorly, okay? So, once again, we're going to make sure I'm going to get double the use here, and I'm going to, oh my goodness, somebody stole my ruler. Found it. How long is side E? 15 exactly. Are we happy with that, everybody? Okay. 15. How long is side F? We're happy with 7.5? Everybody agrees? 7.5? Okay. And how long is side? You want to go 12.5? Okay. Everybody cool with that? Great. Fill in the other side. Fill in the chart. How long is AB? $9.5? Okay, so that's side little c, right? So little c is 9.5. And what did we have here? Little d was 15. Little e was 12.5. And little f was 7.5. Now we still need a and b. There's little a. How long is it? Oh, you guys can't see. Sorry. 4.9. Okay. And how long is little b? We're happy with 8. Okay. Agreed? All right. Now, we already know that angle A and angle F are equal, right? That tells us that triangle ABC is similar to triangle FED, right? Okay. Now, there's another thing that tells us, and all of you already know this, at least I hope you know this. You should have studied this in the 9th grade. If I take angle A, side A, which is what value? 4.9. And I divide it by the value of angle, or side F, what is it? What do I get? Do that with your calculator. And just give me the first decimal point. 0.6. Everyone agree? We only need the 6. Everybody cool? All right. Now, what if I do B and E? 8 and 12.5. What do I get? 0.6. What if I add C and D? 9.5 and 15. And what do I get? 0.6. What do you see? They're all exactly the same. Now, we didn't go any further than that because if we go further than the first decimal, it starts to change a little, right? Why?
Because we didn't measure perfectly.
We didn't measure perfectly, right? We're using this piece of crap ruler, right? Everybody cool? All right. But this property is what allows us to build stuff. Because if you draw a triangle this big on a blueprint, the rules for that triangle follow that triangle. Everybody understand? So, this is what allows us to do this. And this is what you should have been taught by somebody in grade 8 or 9. A, B, C. That is 7. That is 12. And then I come over here. F, E, D. And that is, I'm going to make that angle with an arc, that angle with a star, and that angle with a circle. Now, and then I'm going to make that, and I'm going to make that, and I'm going to make that the star. Now, and this I'm going to say is 18. Now, if I tell you that triangle ABC is similar to triangle, what would this one be? FED? FDE. Why? Because I went arc to star to dot, so I got to go arc to star to dot. Yes? Everybody cool? Now, knowing what you know here, you should be able to tell me what side E and side F are. And this you should have already done in grade 8 or 9. If you haven't, then just chill, or if you've forgotten, then just chill, because you know I'm about to show you. But if you do remember how to do it, do it. And I'm just going to take a second to let the people that do remember how to do it, to do it. All right. A divided by F, B divided by E, C divided by D. What did we notice about all those divisions? They were all the same. And why did A have to compare with F? Because they were in the same position, right? Side A was the short side, side F was the short side, right? So, in this new one that I've drawn, I know this side from arc to dot is 12, right? What's the comparison over here? 18. So 12 over 18 has to equal what? 7 over what? Arc to star. 7 over what? E. Now, who remembers how to solve these? Cross. Cross what?
12 times E equals 18 times 7.
Right. That's 12E equals 18 times 7. Right? Then we do algebra. Now, there's a shortcut here. The shortcut is multiply the pair and divide the spare. 18 times 7 divided by 12. That will give you E. What is it? E is 10.5. Perfect. Can you tell me F? Yes or no? What would you do to tell me F? You would have to consider one of them to be 90 degrees, wouldn't you? Because you don't know, you don't have this, so you have nothing to compare it to. Everybody understand? If I told you that F was 14. Could you tell me little a? How? What would you do? Tell me the calculation. 12 over 18 would equal a over 14, because I have the smaller ones first. And then what would be my calculation there? It would be 14 times 12 divided by 18 to give me an answer of what? 9.3. Yep, 9.333. 9 and a third. You need to be good at Pythagoras and this to do trigonometry. But Pythagoras and this is something that you already know, right? Right? Maybe you didn't do that in grade 9, but you should have. At some point, you should have done this in your math careers. If you haven't, it's only one thing, and you've learned it now, right? How do we use that in real life? That is how people use like photographs to reconstruct like a crime scene. You understand what I'm saying? Like they take a picture of a crime scene, and then, you know, there's a dead body on the ground. That body is 6 feet, 2 inches tall. And then they can use that to rebuild the crime scene. Because you know the body in real life is 6 feet, 2 inches. And on the photograph, it's 3 inches. So you can do this comparison. It's also how they do things like when you're standing beside a building, you know how tall it is.
Like scaling things.
Scaling. It's scale drawings. Everybody cool? All right. So I don't want to burn your brains out. Page 51 and 52 is just some Pythagoras work. Okay? You got 18 minutes now. Tomorrow we're going over your test. I'll put up the right answers tomorrow. I know you can all do Pythagoras, but make sure you go through it a bit. Okay? Go.